Good morning, students. I welcome my PharmD students to have this description about volatile oils. They are given in your syllabus. You should know about the details about oils. We know specifically we are studying about two categories: fixed oils or lipids, and then volatile oils. So we should have a detailed study about the general detail about the oils is very important. So I have taken this topic to have detail about the volatile oils, and then we'll go for each drugs. So first, I think you know that pharmacognosy and phytopharmaceuticals for PharmD students in second year, this will be helpful if you follow the general details about volatile oils. Volatile oils are chemically, when we see the details about the structure of the compound, they are terpenoids or hydrocarbons of plant origin having a general formula C5H8N times. We can see even in detail about the terpenoids. And the C5H8N, you should know that what is it? It is a 5 carbon atom compound, and we have come across this a very basic compound which is necessary for a terpenes. It's called isoprene unit. And this isoprene unit will have 5 carbon atoms in various biosynthetic pathways. Also we have studied, especially in the acetyl pathways, when we think about the production of plant sterols. We know that this is the major compound or the major precursor, major starting product from the pyruvic acid of your metabolic pathway, which you might have studied in your biochemistry. In plant biochemistry also it might be detailed, they might have told very clearly. Isoprene unit, 5 carbon atom. In that we might have come across about the that is dimethyl allyl pyrophosphate and pentyl pyrophosphate. We might have pentene, that means here it looks like a tail and a head portion will be there. Tail to tail linkage, head to head linkage, and tail to head linkage is also possible to have 2 isoprene unit, 3 isoprene unit compounds. But usually we are differentiating or we are classifying the terpenoids, monoterpenes with 2 isoprene unit. 4 isoprene unit means diterpenes. 6 means triterpenes. Like that we just made into the classification of terpenoids. That's also very important for us to know about the chemistry behind the volatile oils. So at present, just I want to say terpenoids are the hydrocarbons of the plant origin having general formula C5H8N times, because we use the N number of isoprene units besides the monoterpene, diterpenes, sesquiterpenes, and polyterpenes. They are also oxygenated, hydrogenated and dehydrogenated derivatives. They are also oxygenated, hydrogenated, dehydrogenated derivatives. Basically, terpenoids are volatile substances. They are easily volatile substances which gives fragrance of aroma to plants. They are also as essential oil because they represent essence. They are mainly found in leaves and roots of plants like conifers, citrus and eucalyptus. Citrus and eucalyptus you may be knowing. Conifers means it's a cone-shaped dried plant which is we can see they also having volatile oil component present in them. The term terpene was assigned to the compounds after isolation of volatile liquid terpene from pine trees. Volatile oil get vaporized or evaporates upon exposure to air at normal or original temperature. So they are termed as ethereal oil. So we should know that ethereal oil also other name for volatile oils. Volatile oils generally occurs in plant family like Umbelliferaceae. Umbelliferaceae example coriander, fennel. Gingiberaceae, ginger. Myrtaceae, clove. Piperaceae, black pepper. Rutaceae, lemon, orange. There are many. We have taken the important one which we are going to have a discussion about it. Volatile oils as official oils are of vegetable origin. All official oils normally pre-exist in the plant, stored in a special secretory tissues. Example, in citrus peel, the skin of the citrus fruits. We might have heard about hesperidin, the constituent which is present in the skin of the citrus peels, orange peels, lemon peels. Or in sometimes oil ducts also will be there in Umbelliferaceae fruits. We can see oil ducts. When you take a section of Umbelliferaceae fruits like fennel, coriander, anise, when you take these type of fruits, Umbelliferaceae fruits, we can see oil ducts and even you can see oil cells in the form of vitae, which we can easily observe. Oil cells in Umbelliferaceae fruits. This is just to show you a picture of an orange, the skin which contain the oil cells. But exception is there. Oils are present in the form of glycosides. Oils in bitter almond formed by hydrolysis of glycosides. When you hydrolyze the glycoside present in the almond, you can get the oil. So that's one example. Oils are in bitter almond. They are formed by hydrolysis of exception. We say that oils are present in oil duct or oil cells, but only in bitter almond you should say that it can be formed by hydrolysis of glycosides in bitter almond. This is the bitter almond oil. Nowadays most of them you started using even bitter almond oil for even for vegetable purpose and also even for cosmetic purpose. Both it has more value nowadays. Uses of volatile oils in general, therapeutically, oil of eucalyptus, just simply some example we are denoting. Flavoring like lemon oil or oil of lemon, perfumery oil of rose is an example. There are many. Starting material for any synthesis of compound, they are using oil of turpentine. Antiseptic activity, there are various volatile oils. Due to high phenolic component present, oil of thyme. Also as a preservative, oil of it is interferes with bacterial respiration and acts as an antiseptic. Clove oil, you may be knowing, we are using for many purposes in the dentistry. An antispasmodic spasm, relieves the spasm. Cramps, ginger, lemon balm, rosemary, peppermint, chamomile, fennel, caraway, they all can be used as an antispasmodic agent. And aromatherapy, there are many oils are used in aromatherapy. Chemical test, just we have taken some chemical test, just two. Volatile oil produces temporary strains when it is made a smear on a paper or a cloth. Temporary, but a fixed oil makes permanent. The stain disappears after some time because of volatile in nature, or it volatilizes. The oil volatilizes. Upon addition of Sudan 3 alcoholic solution, when you add a Sudan 3 solution, the second test, in a thin section of volatile containing compound or volatile containing drug, crude drug, red color is formed, reddish color is formed. Sudan 3, what is Sudan 3? It is a lysochrome, or you can say fat soluble dye. Diazo, it is diazo dye. It is structurally related to azobenzene. When few drops of tincture alcana, when you are adding few drops of tincture alcana added on a thin section of the drug, red color develops, which indicates the presence of volatile oil. Tincture alcana, the plant Alcana tinctoria, this is the plant which we can collect the tincture from this plant, and when you add to volatile oil containing a drug or a piece of the section, immediately you can get a red color formation which indicates the presence of volatile oil. Extraction of essential oils from plant material. There are various methods, but generally we know that in our local places which they are following by means of distillation method. But there are many methods are there. In distillation itself we have many types of distillation, and even we can go for extraction method using solvent system, and also we can go for enfluorage technique. It's the latest, and not latest, it's an advanced technology which can get pure and various volatile fragrant products like pomades, concretes, absolutes, which we can prepare from the new methods. So we are starting from one. We will start the ice, how they are doing. Even direct expression also. Direct expression can also be done, preserving, because volatile oils will be easily get deteriorated or easily get escaped when you are using heat. So that's also one type of method which can also be expressed by giving pressure over the oil cells is also possible. In lemon peel, orange peel, it's possible to do by direct expression method or compression method, expression method. So simple expression on pressure, as was the most citrus oils can be prepared, that is called equally method. Equally method. This method is employed for citrus fruit which contain volatile principle. Here the oil containing ducts which contain oil cells are ruptured by mechanical means or manually. By means of this projecting point pins which can open the ducts of the oil cells in the natural crude drug or the peel is possible to remove in one channel. For this purpose, special vessels are taken which contain point projection in the picture which I have shown. Like the raw material is twisted over the projection in clockwise direction. Manually is also possible, mechanically by automatic instruments also possible, which ruptures the cell and the oil comes out. This causes the oil cells to rupture the essential oil and other materials such as pigments to run down in the center of the device, which contain a collection area. The liquid is thereafter separated and the oil is removed from the water base part of the mixture and decanted. Sometimes it may be in emulsion form and then it can be prevented by means of mechanical means, or it can be decanted, it can be separated from the oil components. So this is a small video which I want to show you regarding the oil, how they are extracting. It's amazing to see. I have just made into cut short. They had many. This is the instrument which they are using for collecting the citrus oil extraction by expression method. You see, the oranges, even lemon also can be. This is polycitrus oil extractor, and in the conveyor or in the trolley, these oranges are added. You see how they are moving through the conveyor and getting into that particular area. You can just observe vibrating, rotating, and there is pinpoints of needle shaped which can remove the oil ducts. This is called polycitrus oil extractor, automatic extractor. You can see the skin will be completely removed. We don't want the pulp, we don't want the inner mesocarp area. We want only the epicarp of the fruit. We want only the skin where the oil cells are there. How you can see how they are getting removed by means of mechanical means. You see that pinpoints of needle shaped and completely they removed by means of this pointed apparatus which is present in that automatic machine, which we can observe here. And even lemon, that is orange and this is lemon, both of them we are shown, and both in the same video I just mixed up, and we got the emulsion form removed from the skin, and the emulsion have been your oil water emulsion is completely, we are just trying to remove it by mechanical means, and this will be taken separately. The water component and the solid component can be removed from that oil by means of giving pressure. And you see how interestingly you can get pure oil. You see, this is orange oil, pure orange essential oil, which we can obtain by this expression method. And this is lemon oil, pure lemon oil. So both this company, they were doing separately by means of this method. Very interesting method, but the oil are very costly, which we are preparing from this. And now we are coming to the next step, water distillation in the extraction of essential oil. This is the second method. In the manufacturing of essential oil, using the method of water distillation, the botanical material, maybe leaf, maybe the skin of the fruit, or maybe flower, why not, maybe bark, maybe root, maybe even it may be a skin, outer skin of the bark, cork, you can say. What you are going to do, that is like botanicals are completely immersed in the water and the still is brought to boil. This method protects the oil so extracted to a certain degree, since the surrounding water acts as a barrier to prevent it from overheating. When the condensed material cools down, the water and the essential oil is separated and the oil decanted to be used as essential oil. The water that is so separated is in this process is also used as in marketed as floral waters, also called hydrosol or sweet water, such as rose water, lavender water and orange water. This is hydro distillation process, where we want to show the picture. You can see the plant materials are kept in number 1, number 2, number 3. You can see the water is heated, passes through the material, and the water rises with the steam, and the steam and the floral water which comes out condenses in the condenser, cool, and then you are collecting the floral water, that is hydrosol, used for beautifying cosmetics, home products and various aroma products of water for steam distillation. And even this is the apparatus which we have seen in the laboratory which we have. Here we can separate the oil and the water, and also we can find out how much the percentage yield of volatile oil present by Clavenger's apparatus. That is, Clavenger's apparatus is like Soxhlet apparatus, you can see, but here it contains, including the condenser. It's not separate, the apparatus itself a condenser. We can see here the apparatus showing heating mantle, and the materials which is you want to separate the volatile oil is kept in the round bottom flask, and water is added, and when you heat, the steam containing the essential oil will be coming into the Clavenger apparatus, entering into the condenser area, and there essential oil and water will be collected in the burette like apparatus which you are seeing there. And the stopper, if the volatile oil is heavier than water, it comes in initially at bottom, or if it is lighter than water, and it floats in the water. Volatile oils are also immiscible with water, so it can be easily separated. Water distillation can be done at reduced pressure, even under vacuum, because vacuum, you know that liquids can boil in low temperature. So avoiding the component getting decomposed due to high temperature can be avoided by means of using vacuum. So water distillation can be done at reduced pressure under vacuum to reduce the temperature to less than 100 degrees centigrade. which is beneficial to protection of botanical materials as well as the essential oil, which get decomposed when it is high temperature. Neroli oil, which is sensitive to heat, can therefore be essential extracted using this method. If extended exposure to hot water is not indicated for the particular plant such as lavender, it is best to find an extraction method better suited, like with using vacuum. Any botanical material that contain high amounts of esters do not take well to this extraction method, since the extended exposure of hot water will start to break down the ester to the resultant alcohol and carboxylic acid. So see that it's necessary when you are thinking that if you want to reduce the temperature, which can affect the molecular structure or the chemical nature of the botanical constituents or the botanicals, then we can prefer for vacuum distillation. This is an apparatus which shows vacuum creating. You can see the mantle, heating bath, rotatory flask, which is connected with a motor and a digital converter, and a vacuum gauge which is connected to the round bottom flask. And from there, due to the vacuum connected, the temperature which you are using the controlling at low temperature can be utilized, and the vapors enter into the chamber charging valve and enters into the main condenser, and you will get the receiving flask. The volatile oil can be collected in the discharge valve. So this is the another picture here, that is the biggest instrument which can be used in the industry, which has been displayed here below my picture. Steam distillation of essential oil, that is hydro distillation, water distillation, vacuum distillation. When steam distillation is used in manufacture and the extraction of essential oil, the botanical materials are placed in a still or a perforated still. Steam will be passed through it, forced over the material. The hot steam helps to release the aromatic molecules from the plant material, since the steam forces upon the packets in which the oil are kept in the plant material. The molecules of this volatile oil then escapes from the plant material and evaporate into the steam. The temperature of the steam needs to be carefully controlled, just enough to force the plant material to let go of the essential oil, yet not too hard as to burn the plant material or the essential oil. The steam, which then contains the essential oil, is passed through a cooling system, condenser, a water condenser. The steam which forms a liquid from the essential oil, a water then separated. This is the picture which we can see. There is a green color plant materials are kept. Here in this area, steam boiled, water is boiled, and the steam is connected to a spray from the bottom of the plant material, and then that the evaporated the steam and the volatile components which is taken from the plant material will comes to the condenser and condensed, and there we can see the oil and the water get separated, And the water can also be used as a hydrosol. Water from a volatile oil, and oil can be easily separated if it is lighter than the water in the up, or a lower, we can see if it is heavier than the water. The steam is produced at great pressure than the atmospheric pressure. Therefore, boil at about 100 degrees centigrade, which facilitates the removal of essential oil from the plant material at a faster rate. And it is so doing and in so doing prevents damage to the oil. Some oils like lavender is heat sensitive, thermolabile, and in this extraction, with this extraction method, the oil is not damaged, and ingredients like linalool, acetate, we'll see that linalool acetate will not decompose to linalool and acetic acid. So when you heat the natural compound which is present in lavender, linalool acetate will get decomposed to linalool and acetic acid. So which can be prevented when you are using this steam distillation. Understand? That's what we want to expose here to explain. Hydrodiffusion is essential oil. This is same. Only thing is the steam is not passed from the bottom. The steam is passed from the top to the down. Or we can heat the material by means of microwave also is possible. I have taken a picture of steam passing or microwaves. It's also indirectly heating by means of steam. When essential oil are extracted using hydrodiffusion, it is a type of steam distillation only. But only where it is actually the way in which the steam is introduced into the still is different. That's all. With hydrodiffusion, the steam is spread from the top into the botanical material instead of sending from the bottom in the normal steam distillation. The condensation of the oil containing steam mixture occurs below the area in which the botanical material is held in place by a grill. The main advantage of this method is that less steam is used, shorter processing time, and a higher oil yield. This is one picture which I want to show is how a microwave, instead of steam sending from the top, a microwaves can be used to plant materials and cooler and collecting the oils in the bottom. You can see even it is an apparatus, the main apparatus itself. This is a schematic diagram. The nearby is an apparatus which digital display where we can keep the plant material which you are interested to extract by means of hydrodiffusion from the top, and you can see that is a microwave, and bottom you can see how that is a condenser and collection of the volatile oil is possible from the botanicals. Then solvent extraction methods. When we talk about the broad term of solvent extraction method, it does not only refer to chemical solvent like hexane, but also other forms such as solid oil and fat, as well as carbon dioxide as a solvent system can be used. Solvent extraction is particularly suitable for botanical materials that has a very low yield of essential oil, or where it is made up of most resinous compounds, and as such delivers as a far thinner fragrance than that of distillation. During this type of extraction, non-volatile components of the botanical materials such as wax and pigments are also extracted, and in some cases this is removed during another process. Under solvent extraction, We can list out the method also, like maceration can be done. Enflurage technique is a very important technique, can be performed. And solvent extraction, including using carbon dioxide, liquid carbon dioxide, hexane, ethanol, can also be performed by solvent extraction. That's, we have to discuss about this. And also we can see this is a maceration extraction method. Simple maceration, cold or hot maceration, which is maceration method of flowers are soaked in hot oil to have their cell membranes rupture, and the hot oil then absorbs the essence, and from the oil you can get separated. The oil is then cleared of botanicals and decanted. This is very much same technique used in solvent extraction, where solvents are used instead of hot oil as used in maceration. And when we come to this enflurage method and other technique, we will make it in the second class. I think it's not, it's just you have to remember what we have discussed today. We have just told about the chemical nature of a volatile oil, and we said, we just discussed about the various method of extraction. Extracting by means of not completed, we just came about the direct pressure or expression method, and we have seen the video about how they will extract. And then we discussed about the distillation method. In that hydro diffusion also we have discussed about steam distillation, what is the difference between them and what is the normal distillation. And next class we will continue this by enflurage method, and also we have to discuss about the type of products and byproducts which can be obtained from this method of isolation of the compound, volatile component from the botanicals. Thank you. We'll see again for the next class.